Hi everyone, my name is Rafael Gastrop. I'm from York University, and today I'll be talking about two types of motor learning. So these are de novo learning and motor adaptation. De novo learning is when you establish a response mapping in the brain for you to be able to learn a new motor skill, while motor adaptation is modifying an existing response mapping to bring performance back to an ideal level. So the visual motor rotation task is commonly used to investigate adaptation. So for example, the task here is to bring a cursor to the target as smooth and straight as possible, but when a rotation is introduced, the hand should deviate in a particular direction so that the cursor would be brought to the target correctly. So here in this image, the corresponding colors show how the cursor is rotated 30 degrees relative to the hand position and where the hand should be reaching in order to accomplish the task correctly. For de novo learning, a mirror reversal is usually implemented where the cursor is flipped in the opposite direction of the hand position relative to an invisible vertical mirror axis. I showed the mirror axis here for your reference, but you would notice how as you move further along from the mirror axis, the hand must deviate even much more in order to bring the cursor to the target. So in this study, each participant trained on both perturbations, where the perturbation that an individual started with was counterbalanced across participants, as well as where the perturbation was presented on the workspace. So for example, we would sometimes have the rotation on the horizontal axis, let's say, and the mirror reversal on the vertical axis. And of course, the corresponding target locations were also counterbalanced. So importantly, no effects were observed, suggesting that learning for one perturbation does not affect the other. So we then assessed learning where we measured the percentage of compensation. So here, 100% would be perfect compensation of the perturbation, 0% would be no compensation, and negative values would be compensating in the wrong direction, while anything above 100% would be overcompensating in the correct direction, but it was still an overcompensation. So for the rotation, we see that participants were able to compensate for it and learning was gradual across 90 trials. For the mirror reversal, participants were also able to learn to compensate for it relatively quickly within 90 trials, but you would notice the great variability in learning compared to the rotation. We then assessed reach after effects, which are persistent deviations even if the perturbation has been removed already. So here we looked into washout trials where the cursor was aligned with the hand position again, and you would expect participants to be reaching along the 0% mark here. And we see that for the rotation, we do find evidence of reach after effects, but not so for the mirror reversal, suggesting that you could easily switch between response mappings for de novo learning, but for the visuomotor rotation or motor adaptation, you would need to modify the response mapping. Finally, we looked into reaction and movement times. So we divided the total movement time into reaction and movement times respectively. And we compared both perturbations and their corresponding washout trials with the aligned baseline session, which I show here in black. So reaction times were slower for the rotation, but eventually go back to baseline levels, and their washout trials are not different from the aligned trials. And their movement times seem to be even faster than the aligned session. For the mirror reversal, however, we see that reaction times are even slower, and although they do go back down, they never get close to baseline levels, although their washout trials do. And their movement times do not really differ from the aligned baseline session. So taken together, these behavioral results show the distinct mechanisms between de novo learning and adaptation, so we could then use this paradigm to investigate neural processes underlying these two types of motor learning. And with that, I thank you for your attention, and please feel free to contact me through email or Twitter for any questions that you might have. Thank you.